Something weird just went down at Massie. And I mean weird. SpaceX took a piece of hardware that technically shouldn't be there and stacked it right on top of B-18.3's hot staging assembly. That spot? It's supposed to stay empty until launch day. Always has. This is the first physical piece of V3 hardware we've seen. It's designed to handle over 1,300 tons every single flight. And here's the kicker. SpaceX is willing to delay Flight 12 into February just to test this thing properly. So the question is, what makes this interface so critical that they'd risk letting Artemis 2 launch first? All right, let me take you through what happened, because honestly, nobody expected this. The last road closure of 2025, everyone was watching for B-19 or S-39 to roll out. Flight 12 prep was supposed to be ramping up. Instead, SpaceX wheels out this ring section that nobody's ever seen before. 2 parts, ship skirt and the can crusher interface. Completely new configuration, never tested, never in the production flow, just there. Then, January 2nd, noon, they crane it up and drop it on top of B-18.3. Not next to it, on top. Specifically, on top of the hot staging assembly. Now, here's why that's bizarre. The hot staging structure is already the tallest part of the Super Heavy booster. Nothing, and I mean nothing, goes above it until you're stacking the ship for an actual flight. That's the rule. So why break it now? The answer clicked when you realize what that ring section actually is. It's the aft section of the ship, the part that physically bolts Starship to Super Heavy. By putting it on B-18.3, SpaceX is validating the V3 interface before they build more of them. And look, this tells us something important. The V3 connection is fundamentally different from V2. We knew the booster had a completely redesigned hot staging system. The ship's getting modifications in the engine bay to match. What we're seeing at Massie? That's where these 2 new designs meet for the first time. This interface isn't some minor component. It's the structural handshake between 2 stages that have to work perfectly under insane conditions. Small changes here, major consequences for flight performance, structural limits, reliability, everything. Think about the alternative. They could wait until B-19 and S-39 are fully stacked. Discover a problem then. That wastes months, potentially damages hardware worth tens of millions. Testing at Massie lets them catch issues early, validate the design, refine it while production keeps rolling. But here's what's interesting. Some people think this isn't just a fit check. That ring section simulates the ship's weight, which means engineers can load it up, apply force, see how the hot staging structure handles the stress. They might even add mass to replicate actual flight conditions. Why does that matter? Because the numbers are ridiculous. So SpaceX looked back at the Soviet N-1 rocket from the 1960s for inspiration. Yeah, the one that never successfully flew. But the hot staging approach? Surprisingly elegant, simple, direct. Better heat dissipation, less mass because you're not throwing parts away, lower complexity overall. Less complexity means faster manufacturing, quicker production, easier operations, faster turnaround between flights. All of this feeds into SpaceX's endgame. High cadence, fully reusable operations where the same booster flies dozens, maybe hundreds of times. But simplicity creates a new problem. The hot staging structure is now the direct load-bearing interface. The ship alone weighs over 100 tons empty. Fully fueled, both stages together, you're approaching 1,300 tons sitting on that interface. Let that sink in. 1,300 tons. Through ground ops, transport, fueling, launch, ascent, stage separation. The structure has to handle all of that, repeatedly, without breaking down, because this booster's going to fly again and again. Getting this wrong isn't just, oops, we'll fix it next time. It's a fundamental flaw that affects every Starship going forward. Here's where history matters. Earlier B-18 stress tests hit problems, required redesigns, reinforced components, expensive lessons, time lost. The data from those failures? That's being used right now at Massie. They're essentially testing the future before it happens, making sure B-19's interface is bulletproof before it ever reaches the pad. So here we are. B-19 and S-39 are done, structurally complete. S-39's sitting behind scaffolding in Megabay 2 looking ready to go. Hardware's there, teams are ready, but nothing moves until Massie wraps up. The math is pretty simple. It's already January. Massie testing shows no signs of finishing soon. Interface validation takes time, careful, methodical work. If they're doing stress testing, and it sure looks like they are, that's more days, possibly weeks added to the schedule. February for Flight 12. That's the realistic window now. January's probably off the table. And here's the twist. NASA just confirmed Artemis 2 is targeting February 6th. Bethany Stevens said rollout could happen in under 2 weeks, mid-January. Then propellant loading tests, integrated checks, and a static fire probably 3rd or 4th week of January. So we might actually see SLS, NASA's famously slow, expensive program, launch before Flight 12. That's not what anyone predicted for 2026. Does that mean SpaceX screwed up? No, I don't think so. Look, Flight 12 is one test in a program built for hundreds or thousands of flights. Artemis 2? That's the entire validation of a $30+ billion program. First crewed lunar mission in over 50 years. The stakes are completely different. SpaceX is playing long-term. The V3 interface they're testing now affects B-19, B-20, every booster after that for years. Finding a structural flaw during Flight 12 would be devastating, not just for that mission, but for program credibility and timeline. Testing now, validating thoroughly, building in the lessons learned. That's mature engineering. That's how you go from experimental prototype to operational vehicle. While everyone's focused on Massie and Flight 12, SpaceX just keeps operating everywhere else. 2025 ended with 165 Falcon 9 launches, 5 Starship flights. That momentum rolled straight into 2026. January 2nd, 9:09 p.m. Eastern. Falcon 9 lifts off from California with Cosmos SkyMed for the Italian Space Agency. Booster B1081 lands perfectly, 21st time. Satellite deploys in under 13 minutes. First orbital launch of 2026 worldwide. Clean, efficient, no drama. Then there's Starlink. Michael Nichols, VP of Starlink Engineering, announced they're lowering about 4,400 satellites, half the constellation, from 550 kilometers down to 480 kilometers. Throughout 2026. The reasoning shows how SpaceX thinks long-term. Solar cycles approaching minimum, Atmospheric density drops. Objects decay slower in orbit. At higher altitudes, dead satellites stick around for years. Lower them to 480 kilometers, decay time drops 80%. A satellite that might orbit for 4 years now deorbits in months if it fails. Plus, below 500 kilometers, there's way less debris and fewer other satellites. Lower collision risk, easier conjunction management. With Starlink representing 2/3 of all active satellites, this isn't optional. It's necessary for keeping low Earth orbit sustainable. So what's really happening here? SpaceX is testing the V3 interface at Massie because they're building infrastructure for hundreds of flights, not just Flight 12. Pushing the launch to February to validate a system carrying 1,300 tons repeatedly. That's not a delay, that's smart engineering. This is what growing up looks like for Starship. If this was helpful, hit the like button. Subscribe to New Space Review if you haven't already. Drop your Flight 12 timeline prediction in the comments. I'm curious what you think. And hey, while you're here, check out that video on screen about Dragon solving a lunar problem NASA didn't even see coming. Thanks for watching. Keep looking up.